Are there sex differences in tobacco smoking? Generally, men tend to use all tobacco products at higher rates than women. Footnote 128. In 2015, 16.7% of adult males, and 13.6% of adult females smoked cigarettes. Footnote 129. Such differences may relate to a combination of physiological, particularly ovarian hormones, cultural and behavioral factors. Footnote 130. Results from neuroimaging studies suggest that smoking activates men's reward pathways more than women's. Footnote 131. This finding is consistent with the idea that men smoke for the reinforcing effects of nicotine, whereas women smoke to regulate mood or in response to cigarette-related cues. A study of stress responses and cravings among male and female smokers who were trying to quit found that during abstinence, lower levels of the stress hormone cortisol predicted relapse in men. However, high cortisol levels were predictive of relapse in women. Footnote 132. Other work on abstinence found that smoking a cigarette with nicotine, as compared to a denicotinized cigarette, alleviated the symptoms of withdrawal and negative mood to a greater extent in men than women. Women obtained equal relief from cigarette with and without nicotine, suggesting that they found the drug less rewarding than men. Footnote 133. Cigarette craving is a major reason why smokers find it hard to quit, and this strong urge to smoke can be evoked by sensory cues and stress. Research suggests that women experience stronger craving than men in response to stress. Footnote 134. But men may be more responsive to environmental cues. Footnote 135. Additionally, longitudinal data from international surveys conducted in 4 industrialized countries indicated that men and women did not differ in their desire to quit, plans to quit, or attempts to quit. However, women were 31% less likely to quit successfully. Footnote 136. One reason why women may have difficulty quitting is post-cessation weight gain. This concern should be addressed in behavioral counseling and adjunct treatments for all smokers. Footnote 137. The overall lower cessation rate for women may reflect sex differences in response to particular medications. See, quote, "What are treatments for tobacco dependence?" End quote. For example, varenicline has greater short and immediate term efficacy at 3 and 6 months among women smokers. However, women and men show similar 1-year quit rates when using varenicline. Footnote 138. In contrast, a combination of varenicline plus bupropion was less effective for cessation among women compared with men. Footnote 139. Another particular concern related to tobacco use among women is smoking during pregnancy. See, quote, What are the risks of smoking during pregnancy? End quote. Article is dated January 2020. Next section. Do people with mental illness and substance use disorders use tobacco more often? A larger proportion of people diagnosed with mental disorders report cigarette smoking compared with people without mental disorders. Among U.S. adults in 2019, the percentage who reported past month smoking was 1.8 times higher for those with any past year mental illness than those without. 28.2% versus 15.8%. Footnote 140. Smoking rates are particularly high among people with serious mental illness, those who demonstrate greater functional impairment. While estimates vary, as many as 70 to 85% of people with schizophrenia and as many as 50 to 70% of people with bipolar disorder smoke. Footnote 141 and 142. Rates of smoking among people with mental illness were highest for young adults, those with low levels of education, and those living below the poverty line level. Footnote 143. The 2005 to 2013 National Survey on Drug Use and Health, NSDUH, data indicated that smoking among adults without chronic conditions has declined significantly, but remains higher than those reporting anxiety, depression, and substance use disorders. Footnote 3. Similarly, a recent study based on the 2006 to 2019 NSDUH data showed higher smoking rates in adults with psychiatric disorders than in those without. However, most importantly, smoking rates among adults with major depression and/or substance use disorder declined significantly during 2006 to 2019 in every examined age, sex, racial, and ethnic subgroup, except for non-Hispanic American, Indian, or Alaska Native adults. These results suggest that tobacco cessation is achievable among adults with psychiatric disorders and tobacco use. Footnote 238. Smoking is believed to be more prevalent among people with depression and schizophrenia because nicotine may temporarily lessen the symptoms of these illnesses, such as poor concentration, low mood, and stress. Footnotes 144 to 146. But it is important to note that smoking cessation has been linked with improved mental health, including reduced depression, anxiety and stress, and enhanced mood and quality of life. Footnote 147. In addition to smoking, there is also a higher prevalence of smokeless tobacco use among individuals with anxiety or substance use disorders. Footnote 3. Other research drawing on data from the National Epidemiologic Survey on Alcohol and Related Conditions, NESARC, found that all types of substance dependence were associated with dependence on nicotine. Footnote 148. Smoking is also highly prevalent among people in treatment for substance use disorders. Footnote 149. With most studies finding rates between 65% to 85% among people in addiction treatment. Footnote 149. Additionally, people who smoke with a mental health disorder, tend to smoke more cigarettes than those in the general population. The average number of cigarettes smoked during the past month was higher among those with a mental illness compared with those without one. 331 versus 310 cigarettes. Footnote 150. Higher cigarette consumption is a particular problem for people with serious mental illness, although adults with both tobacco addiction and co-occurring mental disorders, apart from substance use disorders, comprised only 7.1% of the total U.S. population. They consumed 34.2% of all cigarettes smoked in the U.S., according to data from the 2001 to 2002 NESARC. Footnote 151. High prevalence of smoking among people with schizophrenia. Researchers are working to identify the brain circuits that contribute to the high prevalence of smoking among people with schizophrenia. Schizophrenia is associated with widespread reductions in functional connectivity between the dorsal anterior cingulate cortex and diverse parts of the limbic system. One report identified 15 circuits for which the reduction of functional connectivity correlated with severity of nicotine addiction. Footnote 152. People with substance use disorders and other mental illnesses do not quit smoking at the same rate as those in the general population. Footnote 4. Survey responses from people who have smoked at some point during their lives indicated that fewer smokers with mental illnesses had quit compared to those without psychiatric disorders. 47.4% of lifetime smokers without mental illness smoked during the past month, compared with 66% of those with mental illness. Footnote 150. A recent study found that among U.S. adults in 2019, the percentage who reported past month cigarette smoking was higher among those with past year major depressive episodes than those without. 24.2% versus 17.6%. And among those with past year substance, alcohol or drug use disorders than those without. 35.8% versus 16.8%. Footnote 238. Having a mental disorder at the same time of cessation is a risk factor for relapse to smoking, even for those who have sustained abstinence for more than a year. Footnote 153. Many smokers with mental illness want to quit for the same reasons cited by others, such as health and family, but they may be more vulnerable to relapse related to stress and other negative feelings. Footnote 154. The disparity in smoking prevalence is costing lives. A recent study found that tobacco-related diseases accounted for approximately 53% of deaths among people with schizophrenia, 48% among those with bipolar disorder, and 50% among those with depression. Footnote 155. Since the 1980s, many providers have believed that people with schizophrenia smoke to obtain relief from symptoms like poor concentration, low mood, and stress. Footnote 147. But research is now showing that smoking is associated with worse behavioral and physical health outcomes in people with mental illness, and quitting smoking is showing clear benefits for this population. Footnotes 147 and 156. Comprehensive tobacco control programs and enhanced efforts to prevent and treat nicotine addiction among those with mental illness would reduce illness and deaths. Integrated treatment, concurrent therapy for mental illness and nicotine addiction will likely have the best outcomes. Smokers who receive mental health treatment have higher quit rates than those who do not. Footnote 6. Moreover, evidence-based treatments that work in the general population are also effective for people with mental illnesses. For example, people with schizophrenia showed better quit rates with the medication bupropion compared with placebo, and showed no worsening of psychiatric symptoms. Footnotes 158 and 159. A combination of the medication varenicline and behavioral support has shown promise for helping people with bipolar and major depressive disorders. A combination of the medication varenicline and behavioral support has shown promise for helping people with bipolar and major depressive disorders. Quit, with no worsening of psychiatric symptoms. Footnote 160. A clinical trial found that a combination of varenicline and cognitive behavioral therapy, CBT, was more effective than CBT alone for helping people with serious mental illness stop smoking for a prolonged period after 1 year of treatment and at 6 months after treatment ended. Footnote 161. This section is dated January 2018. Moving on to the next section. What are treatments for tobacco dependence? There are effective treatments that support tobacco cessation, including both behavioral therapies and FDA-approved medications. FDA-approved pharmacotherapies include various forms of nicotine replacement therapy, as well as bupropion and varenicline. Research indicates that smokers who receive a combination of behavioral treatment and cessation medications quit at higher rates than those who receive minimal intervention. Footnote 37, footnote 40, footnote 162 through footnote 167. Interventions such as brief advice from a healthcare worker, telephone helplines, automated text messaging, and printed self-help materials can also facilitate smoking cessation. Footnote 163. Cessation interventions utilizing mobile devices and social media also show promise in boosting tobacco cessation. Footnote 168. It is important for cessation treatment to be as personalized as possible, as some people smoke to avoid negative effects of withdrawal, while others are more driven by the rewarding aspects of smoking. Surgeon General's report on smoking cessation. The Surgeon General reports on smoking cessation, released in January 2020, offers evidence that smoking cessation is beneficial at any age, improves health status, and enhances quality of life. It also reduces the risk of premature death and can add as much as a decade to life expectancy. The prevalence of tobacco smoke and dependence among adolescents, as well as the neurobiological impact and medical consequences of nicotine exposure, suggest that pediatric primary care settings should deliver tobacco cessation treatments to both youth and parents who use tobacco. Footnote 169. Current clinical guidance does not recommend medications for adolescent tobacco cessation because of a lack of high-quality studies. Footnote 170. However, a combination of behavioral treatments, such as motivational enhancement and CBT, has shown promise for helping adolescents quit tobacco. Footnote 171. More well-designed smoking cessation studies need to be conducted with adolescent smokers, particularly in the area of pharmacologic treatments for nicotine dependence. Footnote 170. Behavioral treatments. Behavioral counseling is typically provided by specialists in smoking cessation for 4 to 8 sessions. Footnote 40. Both in-person and telephone counseling have been found beneficial for patients who are also using cessation medications. Footnote 164. A variety of approaches to smoking cessation counseling are available. Cognitive behavioral therapy, CBT. CBT helps patients identify triggers, the people, places, and things that spur behavior, and teaches them relapse prevention skills. Example, relaxation techniques, and effective coping strategies to avoid smoking in the face of stressful situations and triggers. Footnote 172 and footnote 173. A study that compared CBT and basic health education observed that both interventions reduced nicotine dependence. Footnote 174. However, another study found that among smokers trying to quit with the nicotine replacement therapy, NRT, patch, patients who participated in 6 sessions of intensive group CBT had better quit rates than those who received 6 sessions of general health education. Footnote 175. Motivational interviewing. MI. In MI, counselors help patients explore and resolve their ambivalence about quitting smoking and enhancing their motivation to make healthy changes. MI is patient-focused and non-confrontational, and providers point out discrepancies between patients' goals or values and their current behaviors. They adjust to patients' resistance to change and support self-efficacy and optimism. Footnote 173. Studies of MI suggest that this intervention results in higher quit rates than brief advice to stop smoking or usual care. Footnote 176. Mindfulness. In mindfulness-based smoking cessation treatments, patients learn to increase awareness of and detachment from sensations, thoughts, and cravings that may lead to relapse. Footnote 177. In this therapy, patients purposefully attend to the thoughts that trigger cravings and urges for tobacco, and cognitively reframe them as expected and tolerable. Patients learn techniques that help them tolerate negative emotions, including stress and cravings, without returning to tobacco use or other unhealthy behaviors. Footnote 177. Interest in mindfulness-based treatments has increased during the past decade, and studies show that this approach benefits overall mental health and can prevent relapse to smoking. Footnote 178. However, well-controlled clinical trials are needed. Telephone support and quitlines. As part of tobacco control efforts, all states offer toll-free telephone numbers or quit lines with smoking cessation counselors who provide information and support. 800 quit now or 800-784-8669. Studies of quit line interventions indicate that smokers who call quit lines benefit from these services. Footnote 179. Particularly when a counselor calls them back for multiple sessions. Footnote 180. There is limited evidence on the optimal number of calls needed, but smokers who participated in 3 or more calls had a greater likelihood of quitting compared with those who only received educational materials, brief advice, or pharmacotherapy alone. Footnote 180. Quit lines have also been shown to help smokeless tobacco cessation. Footnote 181. The U.S. Department of Health and Human Services provides a smoking quit line, 877-44-U-QUIT, or 877-448-7848, as well as more information and tools for quitting, including text messages and other telephone-based support, at https://smokefree.gov. Text messaging, web-based services, and social media support. Technology including mobile phones, internet, and social media platforms can be used to provide smoking cessation interventions. These technologies have the power to increase access to care by extending the work of counselors and overcoming the geographical barriers that may deter people from entering treatment. A review of the literature on technology-based smoking cessation interventions, internet, personal computer, and mobile telephone found that these supports can increase the likelihood of adults quitting, compared with no intervention or self-help information, and they can be a cost-effective adjunct to other treatments. Footnote 182. A technology does not necessarily have to be recent or highly sophisticated to help boost cessation rates. For example, studies suggest that adults who receive encouragement, advice, and quitting tips via text message, a capability on even the most basic mobile devices, show improved quit rates compared with control programs. Footnote 183 and 184. Among adult tobacco users who called a state quit line, most selected an integrated phone/web cessation program in favor of a web-only intervention. Footnote 185. Participants who chose the web-only option tended to be younger and healthier smokers with a higher socioeconomic status. These participants tended to interact intensely with the site once, but did not re-engage as much as those who opted for the phone/web combination. A review of internet-based smoking cessation programs for adults suggested that interactive internet-based interventions are tailored to individual needs can help people quit for 6 months or longer. Footnote 186 and 187. Future research should determine the effectiveness of different technologies for smoking cessation support among populations that may be hard to reach, including those of low socioeconomic status and adults older than age 50. Technology-based cessation interventions are particularly relevant to young adults aged 18 to 25, about 3.2 million of whom smoked daily in 2016. Footnote 7. A systematic review and meta-analysis of published randomized trials of technology-based interventions, including computer programs, internet, telephone, and text messaging for smoking cessation among this population, found that they increased abstinence by 1.5 times that of comparison subjects. Footnote 188. Researchers recommend embedding cessation interventions in commonly used social networking platforms. Footnote 189. And there has been some exploratory work in this area. Results of a trial with a relatively small number of participants suggested that Facebook was an accessible, low-cost platform for engaging with young adults considering cessation. However, the study pointed to challenges such as maintaining participation and retaining young people in the program. Footnote 189. A randomized controlled trial has been designed to test a stage-based smoking cessation intervention on Facebook tailored for smokers aged 18 to 25. Participants will be recruited online, randomly assigned to a Facebook group according to their readiness to quit, and will receive tailored daily messages and weekly counseling. The study will assess the intervention's impact on abstinence from smoking 3, 6, and 12 months after treatment, number of cigarettes smoked, quit attempts lasting 24 hours or more, and commitment to abstinence. Footnote 190. Smoking cessation for pregnant women. Given the risks associated with smoking during pregnancy, but also the challenges faced by all smokers when trying to quit, researchers have studied an array of approaches to improve cessation rates for this population. Many women are motivated to quit during pregnancy, but like other smokers, most will need assistance. Studies show that behavioral treatments are effective, whereas pharmacotherapies have only marginal success. Footnote 191. A combination of incentives and behavioral counseling is most effective for pregnant women. Footnote 192. Adding vouchers to routine care, which include free nicotine replacement therapy for 10 weeks and 4 weekly support phone calls, more than doubled cessation rates during pregnancy. Footnote 193. Pooled results of behavioral intervention studies indicate that treatment reduced preterm births and the proportion of infants born with low birth weight compared with usual care. Footnote 194. This finding is supported by an analysis of pooled results from studies with economically disadvantaged pregnant smokers, which found that voucher-based incentives improved sonographically estimated fetal growth, birth weight, and percentage of low birth weight deliveries, and breastfeeding duration. Footnote 195. and 196. Medications. Nicotine replacement therapy, NRT. A variety of formulations of nicotine NRTs are available over the counter, including the transdermal patch, spray, gum, and lozenges, and are equally effective for cessation. Footnotes 37, 38, 197, 198. NRTs stimulate the brain receptors targeted by nicotine, helping relieve nicotine withdrawal symptoms and cravings that lead to relapse. Footnote 37. Many people use NRT to help them get through the early stages of cessation, and those with more severe nicotine addiction can benefit from longer-term treatment. Use of NRT improves smoking cessation outcomes, and adding behavioral therapies further increases quitting rates. Footnote 198. A combination of continual nicotine delivery through the transdermal patch and one other form of nicotine taken as needed. Example: lozenge, gum, nasal spray, inhaler, has been found to be more effective at relieving withdrawal symptoms and cravings than a single type of NRT. Footnotes 37, 167, 198. Researchers estimate that NRT increases quit rates by 50 to 70%. Footnote 37. Using the patch for up to 24 weeks has been shown to be safe. Footnote 39. Nicotine replacement therapy, NRT. A variety of formulations of nicotine NRTs are available over the counter, including the transdermal patch, spray, bupropion, immediate release and extended release, was originally approved as an antidepressant. It works by inhibiting the reuptake of the brain chemicals norepinephrine and dopamine, as well as stimulating their release. Bupropion has been found to increase quit rates compared with placebo in both short and long-term follow-up studies. Footnotes 166, 198, and 199. And is indicated for smoking cessation. It is equally effective to NRT. Footnote 167. Varenicline. Varenicline helps reduce nicotine cravings by stimulating the alpha-4 beta-2 nicotinic receptor, but to a lesser degree than nicotine. Varenicline boosts the odds of successfully quitting compared with unassisted attempts. Footnote 198. Varenicline increased the likelihood of quitting compared with placebo, and some studies find that it is more effective than single forms of NRT. Footnotes 200 and 201. And bupropion. Footnote 167. In a primary care setting, 44% of patients on varenicline, either alone or combined with counseling, were abstinent at the 2-year follow-up. Patients who participated in group therapy and adhered to the medication were more likely to remain abstinent. Footnote 202. Research also suggests that this medication may be more effective than bupropion. Footnote 199. Medication combinations. Some studies suggest that combining NRT with other medications may facilitate cessation. For example, a meta-analysis found that a combination of varenicline and NRT, especially providing a nicotine patch prior to cessation, was more effective than varenicline alone. Footnote 203. Similarly, adding bupropion to NRT also improved cessation rates. Footnote 199. For smokers who could not cut down significantly by using the NRT patch, combining extended-release bupropion and varenicline was more effective than placebo, particularly for men and those who were severely nicotine dependent. Footnote 139. Other antidepressants. In addition to bupropion, some other antidepressant medications have also been found effective for smoking cessation, independent of their antidepressant effects, and are considered as second-line treatments. A few small studies suggest that nortriptyline is equally effective as NRT. Footnotes 167 and 199. Although nortriptyline may have side effects in some patients, the small studies for its use in smoking cessation have not reported any. Footnote 199. Researchers have not observed any impact of selective serotonin reuptake inhibitors, SSRIs. Example: fluoxetine, paroxetine, and sertraline on smoking, either alone or in combination with NRT. Footnote 199. Precision medicine. Researchers have been examining ways to personalize treatment based on important individual biological differences, including genetic differences. The field of pharmacogenetics examines how genes influence therapeutic response to medications, providing critical information to help tailor pharmacotherapies to the individual for maximum benefit. For example, people metabolize nicotine at different rates because of variations in several genes. Individuals who metabolize nicotine quickly smoke more, show greater dependence, and have more difficulty quitting. Footnote 204. Such genetic variation influences the therapeutic responses to NRT and other cessation medications. Footnotes 204 and 205. A recent study compared rates of abstinence 1 week after treatment for slow, normal, and fast metabolizers of nicotine who weren't randomly assigned to either placebo, NRT, or varenicline. Results indicated that varenicline worked best for normal nicotine metabolizers, whereas NRT patches were most effective for slow metabolizers. Footnotes 205 and 206. Promising medications and ongoing research. NIDA supports research to develop new and improved current treatment options for smoking cessation based on growing understanding of the neurobiology of addiction. In the area of medications, research is focusing on the receptors targeted by nicotine and the brain circuits and regions known to influence nicotine consumption. Footnote 208. Newer brain targets, including the orexin and glutamate signaling systems, have also shown promise for medication treatment. Footnote 207 and 208. Repurposing medications already on the market for other indications may also prove useful in the search for new smoking cessation therapies. Footnotes 209 and 210. This approach has been successful in the past, as bupropion was an established antidepressant before the FDA approved it as a smoking cessation medication. One current candidate is N-acetylcysteine a medication for acetaminophen overdose, which has shown promise as a treatment for various substance use disorders, including nicotine dependence. Footnote 211. Another approach that could prevent relapse and that has shown promise in early studies is a nicotine vaccine, which would generate antibodies that keep nicotine from reaching the brain. Footnote 212 and 213. Transcranial magnetic stimulation. Transcranial magnetic stimulation, TMS, is a relatively new approach being tested to treat addiction. It is a physiological intervention that non-invasively stimulates neural activity in targeted areas of the brain using magnetic fields. Multiple TMS pulses given consecutively are referred to as repetitive TMS, or lowercase r, capital TMS. The FDA has approved 2 rTMS devices for depression treatment in adults. Research on rTMS as a treatment for smoking cessation is in early stages but has shown promise. Footnote 214 and 215. Among adult smokers who had not been able to quit using other treatments, high-frequency TMS treatment significantly reduced the number of cigarettes smoked. Combining high-frequency TMS with exposure to smoking cues improved effectiveness and boosted overall abstinence rate to 44% at the end of the treatment. 6 months after treatment, 33% of participants remained abstinent from cigarettes. Future randomized controlled clinical trials with large amounts of patients will be needed to establish its efficacy for smoking cessation. This section is dated January 2020. Moving on to the next section. How can we prevent tobacco use? The medical consequences of tobacco use, including secondhand exposure, make tobacco control and smoking prevention crucial parts of any public health strategy. Since the first Surgeon General's report on smoking and health in 1964, states and communities have made efforts to reduce initiation of smoking, decrease exposure to smoke, and increase cessation. Researchers estimate that these tobacco control efforts are associated with averting an estimated 8 million premature deaths and extending the average life expectancy of men by 2.3 years and of women by 1.6 years. Footnote 18. But there is a long way yet to go. Roughly 5.6 million adolescents under age 18 are expected to die prematurely as a result of an illness related to smoking. Footnote 13. Prevention can take the form of policy-level measures, such as increased taxation of tobacco products, stricter laws and enforcement of laws, regulating who can purchase tobacco products, how and where they can be purchased, where and when they can be used, i.e., smoke-free policies in restaurants, bars, and other public places, and restrictions on advertising and mandatory health warnings on packages. Over 100 studies have shown that higher taxes on cigarettes, for example, produce significant reductions in smoking, especially among youth and lower-income individuals. Footnote 217. Smoke-free workplace laws and restrictions on advertising have also shown benefits. Footnote 218. Prevention can also take place at the school or community level. Merely educating potential smokers about the health risks has not proven effective. Footnote 218. The successful evidence-based interventions aim to reduce or delay initiation of smoking, alcohol use, and illicit drug use, and otherwise improve outcomes for children and teens by reducing or mitigating modifiable risk factors and bolstering protective factors. Risk factors for smoking include having family members or peers who smoke, being in a lower socioeconomic status, living in a neighborhood with high density of tobacco outlets, not participating in team sports, being exposed to smoking in movies, and being sensation-seeking. Footnote 219. Although older teens are more likely to smoke than younger teens, the earlier a person starts smoking or using any addictive substance, the more likely they are to develop an addiction. Males are also more likely to take up smoking in adolescence than females. Some evidence-based interventions show lasting effects on reducing smoking initiation. For instance, communities utilizing the intervention delivery system, communities that care, CTC, for students aged 10 to 14, shows sustained reduction in male cigarette initiation up to 9 years after the end of the intervention. Footnote 220. Moving on to the next section. What research is being done on tobacco use? Genetics and epigenetics. Let me read the above sentence first. New scientific developments can improve our understanding of nicotine addiction and spur the development of better prevention and treatment strategies. An estimated 50 to 75% of the risk for nicotine addiction is attributed to genetic factors. Footnote 221. A cluster of genes, CHRNA5 CHRNA3 CHRNB4 on chromosome 15 that encode the A5, A3, and B4 or perhaps it means alpha 5, alpha 3, and beta 4 protein subunits that make up the brain receptor for nicotine, footnotes 221 to 223, are particularly implicated in nicotine dependence and smoking among people of European descent. Variation in the CHRNA5 gene influences the effectiveness of combination NRT, but not varenicline. Footnote 224. Other research has identified genes that influence nicotine metabolism and therefore the number of cigarettes smoked. Footnote 225. Responsiveness to medication, footnote 204 to 205, and chances of successfully quitting, footnote 226. For example, the therapeutic response to varenicline is associated with variants for the CHRNB2, CHRNA5, and CHRNA4 genes, while bupropion-related cessation is linked with variation in genes that affect nicotine metabolism. Footnote 227. Smoking can also lead to persistent changes in gene expression, epigenetic changes, which may contribute to associated medical consequences over the long term, even following cessation. Footnote 228. Epigenetic changes may serve as a potential biomarker for prenatal tobacco smoke exposure. Researchers found tobacco-specific changes at 26 sites on the epigenome, and this pattern predicted prenatal exposure with 81% accuracy. Footnote 229. A large-scale meta-analysis of data on epigenetic changes associated with prenatal exposure to cigarette smoke also identified many epigenetic changes that persisted into later childhood. Footnote 230. More research is needed to understand the long-term health impacts of these changes. Neuroimaging. Cutting-edge neuroimaging technologies have identified brain changes associated with nicotine dependence and smoking. Using functional magnetic resonance imaging, fMRI, scientists can visualize smokers' brains as they respond to cigarette-associated cues that can trigger cravings and relapse. Footnote 231. Such research may lead to a biomarker for relapse risk and for monitoring treatment progress, as well as point to regions of the brain involved in the development of nicotine addiction. Footnote 29. A neuroimaging technology called default mode or resting state fMRI, RS-fMRI, reveals intrinsic brain activity when people are alert but not performing a particular task. Using this technique, researchers are examining the neurobiological profile associated with withdrawal and how nicotine impacts cognition. Footnote 232. Comparisons between smokers and non-smokers suggest that chronic nicotine may weaken connectivity with brain circuits. within brain circuits, involved in planning, paying attention, and behavioral control, possibly contributing to difficulty with quitting. Footnote 233. fMRI studies also reveal the impact of smoking cessation medications on the brain, particularly how they modulate the activity of different brain regions to alleviate withdrawal symptoms and reduce smoking. A review of these studies suggested that NRT enhances cognition during withdrawal by modulating activity in default network regions, but may not affect neural circuits associated with nicotine addiction. Footnote 234. Some imaging techniques allow researchers to visualize neurotransmitters and their receptors, further informing our understanding of nicotine addiction and its treatments. Footnote 27. Using these techniques, researchers have established that smoking increases the number of brain receptors for nicotine. Individuals who show greater receptor upregulation are less likely to stop smoking. Footnote 28. Combining neuroimaging and genetics may yield particularly useful information for improving and tailoring treatment. For example, non-smoking adolescents with a particular variant in the CHRNA5-CHRNA3-CHRNB4 gene cluster, which is associated with nicotine dependence and smoking, showed reduced brain activity in response to reward in the stratum, as well as the orbitofrontal and anterior cingulate cortex. This finding suggests that genetics can influence how the brain processes rewards, which may influence vulnerability to nicotine dependence. Footnote 235. Neuroimaging genetics also shows that other genes, including ones that influence dopamine neurotransmission, influence reward sensitivity and risk for addiction to nicotine. Footnote 236. References. I will not be reading these, but I will just be scrolling past them for the video. These are all the footnotes that I have been reading. And the last section is where can I get further information about tobacco/nicotine. And the NIDA, National Institute on Drug Abuse website includes various information, including information in Spanish, different websites and web pages, physician information, and other websites. And that concludes my reading of Tobacco, Nicotine, and E-Cigarettes Research Report.